Hi everyone, in this video we will discuss all the type B questions from the chapter 6 of standard 12, that is recursion. Now let's proceed. The first question is like this: consider square numbers defined as follows: compute of 1 is equal to 1 and compute of n is equal to compute of n minus 1 plus 2n minus 1. According to this definition, what is compute of 3? Now the answer here is compute of 3 is equal to compute of 2 plus 2 into 3 minus 1, that is 2n minus 1. So this is the answer, which is option C. The next question is, look at compute numbers again. Consider the same method. Which function successfully implements it? Now here the function goes like this: def of compute n. If n equal to 1, return 1, else return compute of n minus 1 plus 2n minus 1, which is the option B. Now look at compute numbers again. Now how many invocations will there be on the call stack for compute of 5? Now to compute 5, it has to call, first of all, compute 5 will be called first. Next, in turn, it will call compute of 4, then compute of 3, then compute of 2 and compute of 1. So the answer is option C, 5. Now predict the output of the following codes. Here there is a function defined called codo with n as its parameter. If n equal to 0, print finally, else print n. And again codo is called recursively with argument n minus 3. Now if you call the recursive function codo with value 15, then the output is like this. First it will print 15 because the else part will be executed because n is not equal to 0, so it will print n as it is 15. Now codo will be called with n minus 3, that is 12, then that is also printed like this. It will print 12, then 9, then 6, then 3, then n will become 0 and it will print finally and come out of the program. In the next case, the same function codo is there, but here the recursive statement is this: codo is called with argument n minus 2. In that case, what will happen? First, the codo will be called with value 15. Next time it will be called with the value 13 because n minus 2. So then it will be 11, then 9, like this it will continue, but n value will never reach 0. So it will not stop executing. That means termination condition will never be satisfied. So this code will give an error as maximum recursion depth will be reached and base case will never be met as n value will never be 0. So this piece of code will raise an error. Now again we'll consider the same code. Here, the recursive call is like this: codo of n minus 2, and the function is called with a value 10. So what will happen? First, codo will be called with 10, then it's having value 8, then 6, 4, 2, like this. Then when it will reach 0, it will print finally and come out. Now again consider the same function codo, but here the recursive call is codo of n minus 3 and we are calling the function with the value 10. So what will happen? N will never be 0. That means base case will never be satisfied. So this piece of code will also give an error because maximum recursion depth will be reached and base case will never be met as n will never be 0. Now predict the output of the following code. There is a function called express which is defined with some parameters x and n. The first condition is if n is equal to 0, return 1, else if n percent 2 equal to 0, return express of x square n by 2. That means express function is called recursively with the values x square and n by 2. Else return x into express of x n minus 1. Again express function is called with the values x and n minus 1. Now we are calling the function express with the values 2 and 5. Now let's see the output. The first case, it will call with the values 2 and 5. 2 and 5 means first if condition will not be satisfied, elif condition will also not be satisfied, so it will go to the else condition. That means return x into express of x n minus 1. That means 2 into express of 2 into 2 comma 4. Else part is executed. Now express of 2 and 4 will be express of 4 comma 2, that is elif part is executed where n percentage 2 equal to 0. Now express function will be called with x square and n by 2. So express of 2 comma 4 will call express of 4 comma 2. Now express of 4 comma 2 will again call the elif part, that is it is satisfying the elif condition. So express of 4 comma 2 will call express of 4 square comma 2 by 2, that is 16 comma 1. Elif part gets executed. Now express of 16 comma 1, here else part gets executed, so it will return 16 into express of 16 comma 0, where already 2 is already there, so 2 into 16 into express of 16 comma 0 will get executed. Now express of 16 comma 0, here if condition is satisfied, so it will return 1. So in turn, finally it will return 2 into 16 into 1, that is 32. Now consider this recursive function and find check of 8. Now there is a recursive function check is there. If n less than equal to 1, return true. If n percent 2 equal to 0, return check of n by 2. Else return check of n by 1. Now print check of 8. Now first when check of 8 is called, it will in turn call check of 8 by 2. So check of 8 by 2 is equal to check of 4, which will call check of 2 by 2. Now check of 2 by 2 will call check of 1, that is true. Hence it will return true. What happens if you evaluate the above code with check of 3? Now let's see. Once we call check of 3, it will call check of 3 by 1, that is same check of 3. Again check of 3 will call same check of 3 by 1, that is again check of 3. That means the 3 value will continue as it is. Its value will not change and it will never meet any base case condition. So this will continue indefinitely and n value will never be less than equal to 1. Hence it will throw error. Now consider the recursive function fn of n and what will be the output produced by the following function calls: fn of 12, fn of 10, fn of 7. Now let's see. Now here a function fn is defined with a parameter n. First of all, it will print the value of n. Then it will check if n is less than 3, it will return n. Otherwise, it will return fn of n floor division 2 minus fn of n floor division 3. That means you can see fn function is called recursively like this. And finally, we are calling this function fn with the value 12. You can see the output is like this. First of all, it will call fn of 12, which is not less than 3, so it will execute the else part, that is it will return fn of 12 by 2, that is 6, minus fn of 12 by 3, that is 4. Now again fn of 6 will call fn of 3 minus fn of 2, and fn of 4 will call fn of 2 minus fn of 1, like this. Now fn of 3 will call fn of 1 minus fn of 1, that is 3 by 2 is 1 and 3 by 3 is also 1, like this. So once fn of 1 is reached or fn of 2 is reached, the corresponding value 1 or 2 will be printed as it is. You can see finally it is 1 minus 1 minus 2, that is in turn that is 0 minus 2, that is minus 2, minus of 2 minus 1, that is 1. So minus 2 minus 1, that is minus 3. And you can see the output will be in this sequence. First of all, fn of 12 is called, so it will print the value as 12 first of all. Next it will print the value as 6. then 3, then 1. You can see the execution has shown a tree structure. You can see here the outputs are shown like this: 12, 6, 3, 1, then 1, 2, 1, sorry, 1, 1, 2, then 4, 2, 1, minus 3. If you can see, thoroughly check this tree. Here we are doing a depth first search. You can see, just check the left side of the tree. 12, then 6, then 3, then 1. Then again go back, go up. That is 1 and 2. Then it is going to the right part of the tree, that is 4. Then it will traverse the left side of the right part, that is 4, then 2, then again 1, and finally the result, that is minus 3, that is printed. So always this type of codes will be executing in this tree form. So this is called depth first search technique. The output is printed in that way. Here you can see the function is called with the value 10. So it will execute like this: function of 10 will call function of 5 minus function of 3. Function of 5 will be function of 2 minus function of 1, and function of 3 is equal to function of 1 minus function of 1. Then the values will be 2 minus 1 minus 1 minus 1. That is finally 1 it is. So how it will print the values? First it will print 10. That means I will consider this tree. First the vertex of the tree is 10, root of the tree is 10, then the left side is 5, and again left side is 2, and again it will go back 1, that is function of 1, so it will print 1, then function of 3, that is 3, then 1, then 1, like this, and finally 1 is the answer. So that will be printed like this. Now consider the same piece of function, that is df(fn) of n, but here the function is called with the value 7. So once we run this program, we'll get first function of 7 will be called. So 7 will be printed. Then in turn it will call fn of 3 minus fn of 2. Fn of 3 is equal to fn of 1 minus fn of 1. Fn of 2 is directly 2. You can see the output is 1 minus 1 minus 2. That is finally result is minus 2. But the values will be printed in this order: first 7, then 3, then 1, then 1, then 2, then finally the result is minus 2. Now next question is, figure out the problem with the following code that may occur when it is run. The function is like this: df recur, it's taking one value p. If p equal to 0, then print some symbol hash, else recur of p. That means the function recur is called recursively with the same value p. Now p is equal to p minus 1. Now recur is called with 5. Now let's see. So what will happen in that piece of code? The function recur of 5 will be called indefinitely. P value will remain 5 always. Why? Because in a recursive call also we have passed the same value as p. So p value will not change. So p is equal to p minus 1 code will never be reached. So we can make the recursive function call as recur of p minus 1 so that it will work fine. Now the correct code can be def recur of p. If p equal to 0, print hash, else recur of p minus 1. That means every time the recursive function is called, p value will be decreased by 1 and finally it will reach 0, and it will satisfy the best condition and will come out of the loop by printing the hash symbol. Now here we'll consider the programs or the codes given in a checkpoint 6.1, which has some recursive functions that cause infinite recursion. Now we have to make some changes in the definitions of those recursive functions so that they can recur finitely and produce proper output. Now let's begin with the first code, def of print. So here there is a function called print which is defined. You can mark here. Here p is uppercase p. So this is not our normal print function to print something on the screen. So this is a separate print function which is defined by the user, which is taking one character variable as its parameter. If ch not equal to blank space, print ch of 1. Here you can see this print is a normal print statement. And finally, the print function is called with a character k. And you can see this is not a recursive function as the function print is not invoked within itself. The user-defined function print with uppercase P here. This is a recursive function, but there is no recursive call to the function. So to make it recursive, we have to call the function print within the definition of print function itself, with the argument value increased by 1 to get the next character. And again also we can't do any arithmetic operation with the character variable, so we have to use some functions like ord and chr. Ord function is used to convert the character into integer, and chr function is to convert the integer into character. Now the termination condition is until the character reaches, let's say, the character t. Now the recursive function to print a range of alphabets in particular order is as follows. As you can see here, we have modified the code like this. First, the print function is defined with a character variable ch, and the condition is if ch not equal to u, let's say, that means we want to print till t, so I have used the character u to terminate. It will print the character. Now again, the print function is called recursively here with value ch plus 1. But we cannot directly write ch plus 1 as ch is not one integer value. So it has to be converted into integer by using the function ord. And again, to print the corresponding character value of the integer variable, we have converted it into character by using the function chr. Now we are calling the function print with the character k. So it will print all the characters k, l, m, and op till it reaches u. Before it reaches u, it will stop. That means it will print till t. The next piece of code is the same as the code present in question number 9, which is already discussed. You can see here this particular piece of code, def of recur p, which is the condition is if p equal to 0, print hash, else p is equal to p minus 1, recur 1 of p. You can see here within the function definition of recur, we are calling the function recur1. That means a different function is called within another function. So this is not basically recursive function call. And again, recur1 is defined over here and nothing is called inside. So this is actually, there is no recursive call is done in this function. So this piece of code does not contain any recursive function, but we can modify it to give it a recursive look. Now here you can see I have defined the function recur and recur1. Both are recursive functions. Within recur, the recur of p minus 1 is called recursively. You can see here recur is defined a variable p, and within that it is again called with p minus 1. That's a recursive call. Similarly, we have defined another function recur1 with the argument n, and there is also a recursive call, that is recur1 of n minus 5. Now if you call both the functions, both the recursive function with two values, recur with 3 and recur1 with 9, then we'll get the output like this. First one is recur function is called with 3. So it will recursively call first of all 3 minus 1, that is 2, that is then 2 minus 1, that is 1, and 1 minus 1, that is 0. When p becomes 0, it will print hash and will stop there. And second recur1 function is called with a value, let's say 9. Now it will check for the if part. 9 is not divisible by 2, so it will go to the else part. And recur1 is called with new value n minus 5, that is 9 minus 5 and 4. Now it is satisfying if condition. 4% is 2 is 0, so it will print the value 4. Now this piece of code is also not a recursive function because there are two functions defined, check and mate. within check mate is called and within mate check is called. It's not a recursive kind of statements, because in a recursive function, the same function has to be called within its definition. Now, the next code is, there is a function prn number, that is one recursive function which is defined over here with value n. If n equal to 1, it will return else print n, and prn num will be called with a new value n minus 2. Now we are calling this function with the value 7. So what will happen? First, n value is 7, so else part will be executed, it will print 7, and again prn num will be called with 7 minus 2, that is 5. Like this it will continue, and when n will become 1, it will return. So this is a recursive function, it will work fine and will give proper output, but while calling the function, we should always pass an odd number as argument. If we will not pass an odd number or else we'll pass an even number, then n is equal to 1. This condition will never be satisfied. The base condition will never be met. So it will create infinite recursion and the program will throw some error. Now here ends the solution of chapter 6. All the type B questions from chapter 6, that is recursion, we have discussed over here, and if there is any doubt you can put in comment section, and do subscribe to get notified for more new videos. And that's all. Thank you.